In problem 15, we are given the angle and we are given the vector, which is in that case velocity. And we are asked to find the x component and the y component of the vector. Now, x and y components represent the projection of the vector on the x-axis and the y-axis. So the x component here for this vector here will be the projection on the x-axis. So this will be v sub x. And the y component will be the projection on the y-axis, which can be also placed here. So this will be v sub y. Or, of course, this one here. This vector v sub y. Of course, this vector is the same as this vector. So you can see here the y component represents the opposite with respect to the angle, while the x component represents the adjacent. So if you want to find the x and the y component, then use cosine the angle for the x component, because cosine the angle will be the adjacent, which is vx, over the hypotenuse, which is v. And hence the x component of the vector v will be v cosine the angle. So we can now plug the values, and hence Vx will be 55 meters per second times cosine 43 degrees. And I'll let you carry out the calculation. And the same thing for the y component of the vector, since the trigonometric function that relates the y component to the hypotenuse, which is the vector is the hypotenuse, is sine. Sine, the angle, is the opposite, which is v sub y, over the hypotenuse, which is v, the vector v. And now we can solve for v sub y. So we rearrange the equation, solve for v sub y, which is v sine the angle, and then we plug the values. So v sub y will be 55 meters per second times sine 43 degrees, and I'll let you do the calculation. Now in question 16, you do the same thing, but notice here that the x component will be positive because the projection of the vector on the x-axis will be in the positive x direction, while the y component will be negative because the projection of the vector v on the y-axis is in the negative direction, negative y direction.